In this video, we are going to look at graphing linear inequalities in two variables. We have done linear inequalities with one variable where we graph them on the number line. This one is different because we will be graphing it on the coordinate axes with an x and a y, not just one variable. Make sure you watch, you listen, and you take notes on your guided notes half sheet. So let's start by talking about what a linear inequality is. It results when you replace the equal signs in a linear equation by one of our inequality signs. So our inequality signs are less than, greater than, less than or equal to, or greater than or equal to. Remember, the not equal to is also an inequality, but we won't be talking about graphing those today. A solution of an inequality is any ordered pair that makes the inequality true. So when you plug in the x and the y and do your operations, it will result in a true statement. So let's look at example 1, and we'll look at whether or not negative 2 comma 4 is a solution of the inequality 2x minus y is less than negative 3. So I'm going to replace the x with the negative 2 and the y with 4. So I get 2 times negative 2 minus 4 is less than negative 3. And now I'm just going to do my operations. First I'm going to multiply. And then doing my subtraction here. Signs are the same, so I add and keep the sign. So the statement I get when I do my substitution is negative 8 is less than negative 3, which is a true statement. Be careful because they're negative. Negative 8 is less than negative 3 because they're negative. So is it a solution? Since it resulted in a true statement, the answer there is yes. Now we're going to talk about graphing. Before we graph, we want to clarify a couple of things. Remember through the explorations we've been doing in class, if you're you will start by graphing your boundary line, then you will do your shading. Remember when you graph your boundary line, if it has an or equal to, so if it's less than or equal to, or greater than or equal to, you will graph with a solid line. If it is just less than or just greater than, you will graph with a dashed line. Remember the difference is a solid line, you want to include the points on your boundary. A dashed line, you want to not include the points on the boundary. This is the same concept as closed circle versus open circle when you're graphing it in one variable, when you're graphing it on the number line. Now, for shading above, and remember we always follow the y-axis. When we shade above, that's going to be if it's greater than or equal to. And we're going to shade below if it's less than or equal to. Remember, these rules will not work if it is a vertical line. Then we have to talk left or right, but for every other type of line, those rules work. Let's take a look at our first example. And it's going to be a little different than the examples we've been doing in class the last couple of days because this one is in standard form. We want to graph the solution set for 2x minus 3y is less than 12. So we're not in slope-intercept form. Our steps are still the same, except we have to add in solving for y. Now, we want to be careful when you multiply or divide by a negative. Remember, you need to change your inequality sign when you do that. Be careful about that. All right, let's look at our solving for y. I'm going to come down beneath because I didn't leave myself enough room. 2x minus 3y is less than 12. I want to get the y by itself, so I am going to start by subtracting 2x from both sides. So I get negative 3y Don't forget to bring that negative down. These are not like terms, so I can't combine them. And then I need to divide by -3. Right there, bells and whistles should be going off in our brain. We need to change the inequality. I divided by a negative. -3 divided by -3 is 1. 1y is just y. Don't know why I'm messing up here. So I get y is greater than, see how I flipped it? And then here, negative divided by a negative is positive, 2/3 x. And then here, positive divided by a negative is -4. So when I am all done solving for y here, I get y is greater than 2/3 x minus 4. You might want to go back through that one more time. I'm going to pause and clean it up a little bit. Okay, so go through that one more time. Rewatch it if you're still having trouble solving for y. And again, remember I changed my inequality there from a less than to a greater than because I divided by a negative. Okay, coming back up here. We want to graph the boundary line. Now remember, when you graph your boundary line, you want to think about whether or not it's going to be solid or dashed before you graph it. That way you don't have to do any erasing. So our boundary line in this case here we go, is y is greater than 2/3 x minus 4. So my slope is 2/3. My y-intercept is -4. My slope, my slope, and my y-intercept. So I plot my y-intercept at -4. And then count out my slope. Up 2, to the right 3. I'm going to count it out a second time. Up 2, to the right 3. I could also count down 2 and to the left 3. Now in this case, it's strictly a less than. There's no or equal to. So I'm going to have a dashed line. So I've done step 2, which is to graph my boundary line. Now I'm going to shade the appropriate half plane. So I'm either going to shade above or I'm going to shade below. In this case, I want to go to where I have solved for y and look, it's a greater than. So I'm going to go to my y-intercept and I'm going to shade following my y-axis up. So I am shading the top half of this graph. Now my final step is to do a quick check. My final step is to do a quick check. I'm going to take a point, and I'm going to use 0, 0 because it's nice and easy. 0, 0 is shaded. So when I plug in 0, 0 to my original, I should get a true statement. 2 times 0 minus 3 times 0 is less than 12. So 0 minus 0 is less than 12, which ends up being a true statement. It's a true statement and it is shaded. So I can be fairly certain that I shaded in the right direction. I could test a second point if I wanted to, and I will let you do that on your own. So again, as we're graphing our inequalities, it's essentially the same as graphing an equation with two differences. You have to pay attention to whether or not it is solid or dashed for your boundary line. And then you have to shade to include all the points that are either above or below that boundary line.